So this is the problem from tutorial 2, problem number 2.2. Express the following point in cylindrical and spherical coordinates. So first of all, we will talk about the cylindrical coordinates. Cylindrical coordinates. So in cylindrical coordinates, before that we will first express everything in terms of the Cartesian coordinates, and this is your z and then x and y, and you can see suppose there is some point here, so this can be represented as rho, phi and z. So this is the form in cylindrical coordinate system. So what is this angle? Actually the distance, so you can actually in the xy plane how much you move, that is given as the rho, and the angle with respect to the x-axis is your phi, and how much you move up or down, that means how much you move along z-axis, that is your z. So I hope this part is clear to you. Now if we want to find rho, you can see this is the projection on the y-axis and this is the projection of rho on the x-axis. So you can find this distance, this is your distance y and this is your distance x. So it is forming a right angled triangle like this with this angle as phi, and it is forming a right angled triangle. Okay, and this is your y, this is your x, and this is your rho. So you can find this rho as square root of x square plus y square. So I hope this is clear to you. Now if you consider this right angled triangle, you can see then the tan phi is given as the opposite side, that means y divided by x. Okay, so phi you can get it as tan inverse y over x. So in this problem you will be getting the value of rho as root of x square plus y square. And what is x here? You see this is your x, this is your y, and this is your z. Square root of 1 square plus minus 4 the square. So this is equal to root of 1 square is 1 and 4 square is 16, so it is root 17. So this is your rho. So you will get this rho as root 17. So I will mark it in green color. So this is your rho. Now we have to find what is the angle phi. So we will find the angle phi as tan inverse y by x, it is minus 4 by 1. So you will get this angle as minus 75.96. But usually we will be representing phi in terms of a positive quantity. So you can see here, if I am representing it in positive quantity, I will select another color and I will show you. You see the phi is now somewhere here. This is your phi, sorry, your phi is somewhere here. You see this angle you are getting x minus 75.96. That means you are moving in clockwise direction, so in xy plane. So what you can do is that if you want to express phi as a positive quantity, express phi as a positive quantity, what you have to do, you see the total angle in this is actually 360 degrees. So what will be the actual angle phi? So you can see, and this angle is minus 75. So you have to subtract that 75 degrees, or you can say that the phi is given as your minus 75.96 plus 360, or you can say you have to remove that 75.96 from 360. So you will be getting this answer as 284.04 degrees. I hope it is clear to you. Next we will see how to express in spherical coordinate system. So the previous one was cylindrical coordinates. Now we will see the spherical coordinates, how to express these points in spherical coordinate. So you know that this is your z, this is your x, and this is your y axis. Okay. Now in spherical coordinates, any point is given as you see its distance from the origin is r, and its projection onto xy plane is given as something like rho. Let's say this is rho, and this is your angle phi, and this is your angle theta, which is with respect to the z axis. Now you can get this r as root of this length, or I can say, I will remove this notation rho, it may confuse you sometimes, this length plus the square root of the square of this length plus the z square. That means this length is given as root of x square plus y square. The square of that is x square plus y square, and this is z, so plus z square. That is your r. So you, in spherical coordinates, you will be representing it as r, then theta and phi. Now what will be your tan theta? If you consider this particular triangle, I will draw it separately. So this is your triangle. If you consider this triangle as I shown here, you know that this length is root of x square plus y square. That means this length here will be same, that is x square, root of x square plus y square, and this is, you know, this is your r, so this is your r. So what will be tan theta? Tan theta is equal to opposite side divided by the adjacent side. So you know that this distance is z, so tan theta will be equal to, the opposite side is root of x square plus y square divided by the adjacent side is z, so this is your tan theta. Or I can say my theta is equal to tan inverse root of x square plus y square divided by z. So now we will calculate these values. So this is equal to, I will use a separate color, so this is equal to root of x square is, you see, 1 minus 4 and minus 3. This was our point. I think let me check the question again. Yeah, it is 1 minus 4 and minus 3. So 1 square plus minus 4 square plus minus 3 square. So you will get this answer as 4, not 4 point, it is 5.099. Okay. Now we will see what is the value of theta. Theta is equal to tan inverse root of, what is x square, 1 square plus minus 4 square divided by z is minus 3. So this angle, will be, you will be obtaining it as minus 53.95 if you are using the calculators. But you see the angle is negative, and you can see if I draw the z axis, this is your z axis and this is your angle theta, but theta is the angle from the z axis, but you see this is the angle from the z axis, but if you are going in this direction, the angle is negative, and it is given as minus 53.95. That means this angle is like, the total angle is given as, with respect to your xy plane, this is your xy plane. So the total angle with respect to from r to z is theta, but now the angle is minus 53.95. So what you have to do? So in order to convert it into a positive quantity, your theta, if you want to find the theta, you have to add 180 degrees. So 180 plus your this angle, because minus 53.595 degrees. So you will get this answer as 126.040. So whenever the angle is negative, please add 180 degrees. In the case if you are taking the tan inverse in spherical coordinate system. I hope it is clear to you. Now you can find what is the value of phi. So in order to find the value of phi, it is very easy. You know that this particular point, this particular length is root of x square plus y square. So and this length is your y. So I will write it in the next page. So you know this is z axis, this is your x axis, and this is your y axis. I will just show only this part. This distance, you know that this is root of x square plus y square, and the distance here, this is nothing but the projection on the y axis. This is y, and this is your phi. So what is tan phi? Tan phi is equal to opposite side, it is y over this root of x square plus y square, x square plus y square. Sorry, I am wrong. It is like tan theta is the opposite side by adjacent side. Okay. So what is the opposite side for phi? The opposite sides for phi is y, which is equal to y divided by adjacent side is just x. So x. So tan phi is y over x. So phi is equal to tan inverse y over x. What is y over x? What is the value of y? Y is minus 4 and x is 1. So minus 4 over 1. When you do this calculation, you will get it as minus 75.96 degrees. But again you are getting minus 75.96. So it is like you are moving in this direction. That means from the x-axis you are moving in opposite direction here. So actual angle was like in xy plane, it is in anti-clockwise. Now you are moving in clockwise direction. That is why you are getting this angle as minus 75. So if you want to find the actual angle in terms of in a positive quantity, to express as positive quantity, we have to express it in positive quantity, because we have defined phi like that. So we have to take the angle from the x-axis like this. How much will be this angle? So how much will be this angle? That is the question. So this angle, how much will be this angle? So this angle will be, the total angle is 360 minus, that means 360 plus minus 75.96 or 360 minus 75. So this you will get it as 75.96. So your phi as a positive number, as a positive quantity, is given as minus 70 as 360 minus 75.96 degrees. So this answer will be 284.04 degrees. So in spherical coordinates we will be representing it as r, theta and phi, and how much it will be? It will be like, what is r? We have got r as 5.09. you see, this is the r, 5.099, and we got the theta as 126.04. You see, when I find theta, I have used 180 degrees. So this you should be very careful. So while doing the problem, so it is 126.04, 126.04 degrees, then 284.04 degrees. So this is how to represent it in spherical coordinates. I hope it is clear to you. Next, we will discuss about how to find the value of phi in cylindrical and spherical coordinate systems. Okay, and you know that the phi is the angle which is defined with respect to the x-axis. Let us consider the coordinate system, Cartesian coordinate system. This is x and this is your y. So in cylindrical coordinates, what will be the value? What will be the value of rho? You don't know that in cylindrical coordinate we will be representing the coordinates by using rho, phi, and z. Okay, so let us consider a point. Let's say this is the point. Let's say this point is x is equal to 1, then y is equal to 1, and let's say z equal to 0. That means it is in the xy plane. Now this point I can represent with respect to origin. That means the distance from the origin is rho. Okay, this is the distance with respect to the origin, and you know that this is the value of y and this is the value of x. Okay, let us consider this point is x is equal to 1. So that means that this is the distance traveled in x direction, and this is the distance traveled in y direction, and distance traveled in z direction is equal to 0. So in this case, the angle the angle phi is defined with respect to the x-axis, and this is your angle. Now you know that this is y, so this distance also will be y. So tan of phi will be just y over x, or tan inverse y over x will give you the value of phi. So you will get it as tan inverse of 1, y is equal to 1. Okay, y is equal to 1 divided by 1. You can see here that x is positive and y is also positive. So in this case you will get the angle tan inverse 1 over 1 is 45 degrees. I hope this is clear to you. Now we will consider another case. So now you can see here that both x and y are positive. That means that it is in the first quadrant. Okay. Next we will see our x become negative and y become positive. Now we will see the case with x become negative and y become positive. So we will see this as the case 1. Okay, case 1. Now we will see case 2. So the case 2, so in the case 1, what is the highlight? X is positive and y is also positive. Okay, so this is the highlight. Now you see the case 2, we will consider like x as negative and y as positive. So let us consider this z, x and y. Now we will see the point. Let's say this is the point. This is in, okay, I will just show the minus x direction first. So this is the minus x direction. Now let's say this is the point. This is the point with x is equal to minus 1, y is equal to 1. That means this is the y, this is the y, and this is the value of x. So you can see here that x is equal to minus 1, so because this is in the minus x direction, and y is equal to 1, and let us say let us consider z equal to 0. That means it is in the xy plane. Okay, so it can be any value, z can be any value, there is no issue. So we will see this is the line that we can draw from origin to that particular point. Now, if I take the tan inverse of y over x, let us see what we are going to obtain. Tan inverse, what is my y? Y is equal to 1 and x is equal to minus 1. Okay. So, you will get this tan inverse as, you will get it as minus 45 degrees. Okay. So, this minus sign is indicating from which axis that you are taking this. You are taking from the minus x axis. Now, you see here this minus sign is indicating in which direction you are moving, sorry. So, this is the angle, and that is the magnitude of that angle is 45 degrees. Now, it is clear that it is in the second quadrant. Okay. So, this is in the second quadrant. So, because of this reason, you can see here that actual angle that is defined in your cylindrical coordinate system is with respect to the x axis. So, we will start moving from the x axis. So, if you move from the x axis, you see here you will get this angle, you will get actually this much angle. So, this is your phi. And you know that the total angle, that means if you take the whole thing, scenario, the total angle is 180 degrees. So, you can calculate your phi as, you have this 45. So, just 180 then minus this 45, or whatever angle you are getting here, just add 180 to it, you will get the actual angle. So, this is the idea. Okay. So, next we will see what will happen if we are considering the third quadrant. Okay. So, in the third quadrant, so let us consider the case 3, that is the third quadrant. Okay. So, this is your z, this is your x, and this is your y, and this direction will give you the direction minus y, and this direction will give you the minus x. Okay, let us consider some point here. Let's say x is equal to, I will use different color. So, x, this point, x is equal to minus 1, y equal to minus 1, and let us say z equal to 0. Or our case 3 is x is negative, then y is also negative. Okay. So, this means that we are in the third quadrant. Okay. So, what we will get here? You see, this is the this value is minus 1, and how much you move in x direction, that means you are in minus x direction. So, it is minus 1. So, you will get it as the angle, you will get the tan inverse y over x as tan inverse, okay, tan inverse minus 1 over minus 1. So, you will get it as 45 degrees, but actually the angle is not 45 degrees. If you take the angle, you see here that you are getting like 45 degrees, tan inverse of you are getting this angle as actually 45 degrees. So, you are getting actually this angle as 45 degrees, not phi, as 45 degrees now. Okay. Now, 45 degrees. But actually you need the angle like this, you need the angle with respect to the x axis. You see here, this is actually, you need the angle with respect to x axis towards this point. Okay. So, what is the angle here actually? The phi is equal to, you have already 180 degrees along this direction. Let us say this total angle, what you are getting, it is 180 degrees. So, you have this 180 degrees, then you have to add this 45 degrees. Okay. So, the total angle will be 180 plus 45. So, if you are in the third quadrant, your phi is equal to 180 plus this 45. Okay. So, in general you can say, take, if you are in the third quadrant, your phi is equal to 180 degrees plus tan inverse y over x. Here y is negative and x is also negative. Okay, so this is the scenario. Now we will see, this is like, I will generalize this, and in this case you see here the phi is equal to 180 plus tan inverse, you are getting actually negative, so tan inverse y over x. Okay, and here you should note that your x is negative and y is positive. Okay, so this is the scenario. This is in the which quadrant? It is in the second quadrant. Okay, and next here in the case 1, that means you are in the first quadrant. This is the scenario, both are positive, nothing to do. Now we will see the situation with the fourth quadrant, that means case number 4. Okay, so case 4, what is the situation? In the case 4, you are here like this is your z axis, this is your x axis, and this is your y axis. Okay, now in the case 3 you were in the third quadrant. Okay, now in the case 4 actually you have this is as minus y and you have this as minus x. Okay, you are here. So let us consider x is positive. Let's say x is equal to 1, y equal to minus 1, and let's say z equal to 0. So in case 4, x is positive, y is negative, and z equal to, sorry, whatever be the value of z, there is no issue. So y is negative. So we are in the fourth quadrant. Okay, quadrant. So in the fourth quadrant, let us consider the angle. Let us consider the angle. Okay, so when you talk about the angle, if you take the tan inverse y over x, this is equal to tan inverse, your y is minus 1 and x is equal to 1. So in this example, x is equal to 1. So you will again get it as minus 45 degrees. So it is the angle you see here that, so this angle is nothing but the angle between these two. So this is the angle actually. This is the angle. I will draw it properly. So it's like this, and this is x, this is z, and this is y. Okay, so the angle means this angle is 5 degrees because that will give you this y over x. So you are getting this angle, not phi, actually this is the angle that you are getting by tan inverse y over x. So actual angle is actually, you need the angle from the x-axis in this direction, and the whole you need this angle till this point. Okay, so what is that angle? You have this angle as tan inverse, this one you have as tan inverse y over x in case number 4, that means in the fourth quadrant. So how you can find it? You know that the whole angle is 360 degrees. So our phi is nothing but 360. Okay, and you got this angle as minus 45. Okay, that is nothing but tan inverse y by x, or we can say that phi is equal to 360 plus tan inverse y over x. And what is the situation here? Your x is positive and y is negative. I hope this part is clear to you. Okay, so this is the case in finding phi. So this is true for both cylindrical coordinates and spherical coordinates, because in spherical coordinates you know that in spherical coordinates you know that this is z, we have x, this is y. Suppose you have a point in the spherical coordinate system that is a distance r from the origin. Okay, the angle with respect to z axis is given as theta, and its projection on the xy plane is nothing but your rho, and this angle is phi. So the definition for phi is same. The definition for phi is same, but rho is the projection of R on xy plane. That is the only difference. So all the rules for finding phi that I have explained previously, phi in cylindrical coordinates, coordinates is same in case of spherical also, okay, spherical coordinates also, spherical system also, okay, coordinate system also, okay. So that is same. Now we will see what is the situation for the angle theta. So that is the main part that we have to discuss. So how to obtain this angle theta? Okay. Now let us consider the coordinate system. This is z, this is x and y. Let us consider a point here. So if we consider a point here, okay, it can have the value and it is at a distance r from the origin, okay. Now if you project this on the xy plane, you will get this distance as rho, and on the top of this it is also same distance from the origin. So this is also rho, so this is also rho, both are same, okay. Now theta is the angle between this r, the line r and z axis. So line joining the point from the origin and the z axis, okay. So what is tan theta? Tan theta is equal to the opposite side, which is nothing but your rho, by the adjacent side. So the adjacent side is nothing but your value of z. So this is z. And what is the rho? Rho is the projection on the xy plane. You know that rho is equal to root of x square plus y square, okay, because this is the distance y and this is the distance x, and by the we can just find the hypotenuse by as rho is equal to root of x square plus y square, and this number will be always a positive quantity. We will be taking only the positive root, okay. So this will be always positive root. So this will be always a positive quantity. I hope it is clear to you. Now there are only two cases. That means the case 1 is z as positive and the case 2 is z as negative, okay. So if the z is positive, nothing to worry, just you can find theta is equal to tan inverse this rho by z, okay. This is equal to tan inverse root of x square plus y square over z, okay. Now if in the case 2, let us see this case 2 in detail. So in the case 2, what is the situation? This is your z axis, this is your x axis, and this is your y axis. Now let us consider the point somewhere here, okay. So in this case you can see here that this is your rho and your z is negative. Z is equal to is negative. Let us consider this point as, let's say, x is equal to 1, y is equal to 1 and z is equal to minus 1, okay. So let's say this is as 1 by root 2 and minus 1. Now in this case you can see that the angle theta is this much from the z axis. So angle theta is defined from the z axis. But if you take the tan inverse, if you take this tan inverse rho by, okay, z, this will give you tan inverse. What is your rho here? What is your rho here in this example? What is your rho? Rho is equal to root of 1 by root 2 square means 1 by 2. That means 1 by root 2 square plus 1 by root 2 square. So 1 by 2 plus 1 by 2, this is equal to 1. Okay. So you will get it as 1 over and z equal to minus 1. What is z equal to? Minus 1. So you will get it as minus 45 degrees. But minus 45 degrees means this is the angle between this is 45 degrees. That's what we are getting. So to find the actual angle theta, what you have to do? You have to add this with the 180 degrees. So I will take 180 minus 45. Okay. Or I can say my theta is equal to 180 plus tan inverse rho by z. So this is applicable when z is negative. Okay. So this is the rule. So I hope this is clear to you. Thank you.